Well, welcome everybody to another Hydroterra webinar. Thanks very much for attending. Today, our topic is mapping and monitoring the inaccessible, how drone technology and remote sensing are shaping the future for environmental insights. It's proven to be a very popular topic with nearly 300 registrants, so obviously something everyone is looking at. We're very fortunate to be joined by Amy Steiger, who's Chief Remote Pilot and Geospatial Discipline Lead for Australia and New Zealand for Stantec. You've also got myself here. I think most of you know that I'm the Managing Director of Hydroterra. Before we get started, I would like to begin by acknowledging that we conduct our work across this great land, and for that privilege we would like to thank the traditional owners. Hydroterra respectfully acknowledges the Boon Wurrung people of the Kulin Nation, where we are located today, and we pay our respects to their elders, past and present. There's a picture of our presenters. A little bit about our presenter. So Amy Steiger is the Geospatial Discipline Lead for Stantec. She's the Chief Remote Pilot at Stantec, ensuring safety and oversight while delivering high-quality mapping products. With over 18 years of industry experience in geospatial, Amy has been instrumental in advancing the use of drone technology within Stantec since 2013, which is pretty impressive, right? And drones have been around for a while, but not so much in our industry. So that's a really long period of work in there. Her expertise spans across various projects, including infrastructure, transportation, planning, and environmental services. A little bit about what led Amy to be where she is today. Amy originally aspired to be a park ranger, studied science at the University of Wollongong, then discovered the world of GIS. Amy has also undertaken a grad certificate in applied GIS at Albury TAFE. Hobbies: she's an SES volunteer in Cooma. She's into geocaching, which I hadn't heard of until a couple of minutes ago, which is a bit like roganing or going out in the bush and finding things. She likes bushwalking and skiing. We love your questions. Please log your questions using the Q&A button, and I will read those questions out to Amy at the end of the presentation. Many thanks to all of those who have logged early bird questions for this webinar. We have a lot today, so that is great. Thank you. Why does Hydroterra do these webinars? Well, we're into sharing knowledge. We'd like to facilitate education, and we like to take an industry leadership position. So without further ado, I will pass over to Amy.
Thanks, Richard. Thanks everyone for joining. I'm pretty excited to share a few insights. We'll go back to basics a little bit on sort of what drones and remote sensing satellite can do, and go through some limitations and challenges with them as well. And then I've got a few case studies at the end. So kicking off, so what are we talking about when we talk about remote sensing technology? So remote sensing is a method of data collection without actually touching the Earth. So it can be imagery or information that we collect from a satellite. It could be something that we collect from an aircraft or a helicopter. It could be drones, or it could be ROVs or submersible vehicles that are collecting information underwater, or things like bathymetry and sonar as well. So there's a whole range of different examples up there. So a lot of the drones, for example, will be collecting photography or maybe LiDAR. Some of them have multispectral imagery capabilities, could be thermal. More of the hyperspectral and really broad range of sensors are probably mounted on the satellites with things like radar, where you can see through cloud cover, and different sort of weather events, that sort of thing. And then more of that bathymetry, sonar sort of sits on the water side of things. So there's a whole bunch of different ways that we can collect remotely sensed information without actually touching where we're looking, which helps us identify areas that we might not have been able to inspect or access before. And using this technology helps us transform the data into knowledge and how we can apply it to different applications as well.
If you've got a buoy mounted sensor, but the sensor doesn't touch the water, like we've got these hydrospectra scanners that look down and the measurements bounce back, but doesn't actually touch it. Is that remote sensing, just to test your definition?
I think it could be, if it's not actually, if it's
So it's just
collecting
about the
information.
contact.
Yeah,
Right.
yeah. So
Okay.
could be. So first we'll go through drones. So we'll go through what we're talking about when we're talking about drones. So for this purpose, we're talking about drones as remotely piloted aircraft. So they can be flown manually, so sort of free flight, or you can fly them on a mission. So you can pre-program an area of interest, and it'll go through like that top right picture and do like a lawnmower pattern and complete the survey that way. And you can use that the information that it captures on that mission to stitch together into things like aerial photography or creating a surface. There's a whole range of different drones out there. So the one at the bottom right might be one like a little Mavic that you might see a lot more often. It's a little bit more entry level, a bit affordable for sort of recreational pilots as well. All the way through to things like some of the survey drones that we've got there that are a bit bigger, different. They're not multi-rotor, they're sort of fixed wing or powered lift options. So there's really a whole bunch of different applications, and they all have the different benefits and limitations. So I think some of the ones that look a little bit more like a plane, they will cover a larger area, and they can carry sometimes they can carry heavier sensors as well. They can just cover a large area, a bit more like a manned aircraft. But then some of the multi-rotors, you can put all kinds of different sensors on them. So you could put methane sensors or LiDAR sensors and all kinds of different applications, and they can lift things like tanks to do spraying and that sort of thing. But you can't cover the areas that some of the plane options can as well. So on the next slide, we'll go through some benefits of drones. So like Richard said, I've been flying drones since 2013, which was, I guess, quite early in the industry when drones were kind of coming out. So I got into drones when our survey team started using them for photogrammetry mapping of sort of quarries and landfill sites. And then since then, we've sort of diversified a little bit and looked at all the other options of what we can use drones for. So there's sort of three different categories that I've grouped them into in terms of what are some of the benefits of using drones. So we've got time, cost, technology, and health and safety. So for the time, the drones are really easy to mobilize, can fit in your backpack. You can kind of drive to site, set them up and off they go. I guess it does come with a bit of a caveat, I guess, in my experience with flying drones that, I don't know, it's never quite as straightforward as getting there and flying. Probably about 80% troubleshooting before you can just kind of fly as well. So there's always something little to fix, and something won't connect or something's not quite working. So yeah, they are. But once they're up and running, they're quick. You can repeat the mission. So over and over again, you can have your site and you can go there every week. You could go there every day. You can fly exactly the same mission, go to exactly the same coordinates, take a photo at the same waypoint, and you can fly it over and over again. And I think having that repeatable information just really helps with some of the analytics that you can do later as well. Our WA team came up with this stat. I don't know, they say, what is it, 90% of stats are made up, but they decided that using drones for them on site was 90% faster than doing a traditional survey in complex terrain. But the terrain they were talking about sort of like that top image, so you can understand why doing that on foot to do a survey would be quite tricky. So for technology, a lot of the imagery that you can get off a drone is quite high resolution, and because you're flying a lot closer to the ground than a plane or a satellite, you can get really high resolution imagery, which you can use to help with precise, pulling out precise analytics of your area as well. The precise measurements, I guess, comes back to the survey grade component. So any of these applications that you're doing with drones, you can use the onboard GPS or higher accuracy GPS to get really high accurate resolution horizontal and vertically for the information that you're collecting, particularly for elevation data.
So how accurate is the elevation data that you collect with a drone?
So when we're doing a survey grade drone mission, sort of once all our survey control points and the base stations all set up, without really trying, we kind of just say it's plus or minus 40 mil. So it can be a lot better, but 40 mil is just a good, I guess, guideline of just that if you're using survey grade, that's the sort of level of accuracy you can get, but it's probably a lot better.
Sort of thinking about surveying monitoring wells, to get your RLs for top of casing. Do you ever use drones to zip around and land on
No,
top of them, or do you not
no,
need to land on them? You just no one's
no,
using
I
it for that.
haven't heard of that though.
Okay.
So I guess when we're doing our survey mapping, so you can either use the photogrammetry using the photos that the mission will collect to pull that together into a elevation data, which works really well for sort of bare ground or quarries and sort of landfill sites. That's where the photogrammetry will really work well for collecting topographic information. But once you start to get sort of vegetation cover, the elevation data using photogrammetry will start to get less detail because it's picking up the top of all the vegetation, anything that it can see sort of starts to build a surface model rather than a terrain model. But you can get LiDAR sensors, which you can mount on drones as well, which will start to give you that insight and penetrate the canopy down to the ground level as well. But so I guess if you're using LiDAR, you could potentially pick up the top of some wells with that as well. And thinking back to the last slide, there's all different platforms and sensors that suit different applications. So there's sort of different drones are specialized for different purposes, from doing a really large survey area down to identifying cracks in like a bridge or a structure or a water tank, that sort of thing. So you can be sort of two extremes on what you can use the technology for. And the biggest thing is that we found useful is health and safety. And I think a lot of our, some of our examples later will talk to that, but just reducing staff on the ground in potentially hazardous environments. So areas that might be prone to rockfall, or in a coastal environment, if you've got a rock shelf that the teams were going to have to walk over in a high swell, then using the drones is definitely a lot safer. But you can also put the drones into situations like areas where there might be sort of air quality or like pipes and things where you wouldn't send people, so confined spaces as well. So you can get drones that have like a cage on them to help you fly in those sort of GPS denied environments. So there's a whole range of different applications. So moving on to some opportunities. So I talked a little bit about some of the photogrammetry and the survey side of things, but there's a whole range of different applications, and there's always new sensors and new technology coming as well. So if you can measure something with like a handheld sensor, you can usually measure it on a drone. So some other applications, we don't do all of these applications, but just to give you an idea of what is possible. So things like air and water quality, radiation sensors, methane gas. There's applications where you can use drones for rehabilitation. So you can mount seed buckets, I guess, on the bottom of a drone, and do sort of revegetation exercises. You can do weed spraying. You can look at vegetation health, or looking at things like soil staining and different change of colour over time. We've used it on some of our mine sites to help with mustering cattle. So things like, things that you wouldn't think you can use it for.
Have you done that, Amy? Have you
I haven't
the
personally,
cows?
but someone has herded up cows on a mine site to get them out of a paddock they weren't supposed to be in. And then again, just improved safety. So being able to access areas that you probably couldn't walk down to survey, or if there was like an abandoned mine shaft or area you don't want any vehicles or people going to. Or also it could be, we've used them for sort of, looking at bat roosting areas, so on a cliff, unless you get sort of rope access and looking at the caves and little hollows on the cliff face. But you could also send a drone and then have it look at what habitat is in that cliff face as well, without sending a rope team down.
Just looking at that abandoned mine openings, so have you flown drones in underground workings?
We don't, but there are definitely groups that do fly drones underground. So there's some drones that can they call it SLAM. So it can use like a LiDAR sensor that kind of generates where it's going, I guess on its way. And so it can use that to help identify where hazards or walls are, and sort of help find its way through there as well.
So just going back about LiDAR, that seems to come up a bit. So why can LiDAR see through the vegetation canopy?
So LiDAR uses like multiple pulse returns from the sensor. So the first return will generally be the top of the vegetation, and as more LiDAR pulses, I guess, go through the vegetation canopy, the last one is normally the ground level. So it'll send off millions of points, but just so yeah, the data sets are quite enormous, and particularly from a drone, it's all a lot closer and everything's a lot. You get a lot of data, so that's something to consider as well. But the LiDAR will give you the top of the vegetation and then the ground level. It depends how dense the canopy is. So there's still some really dense canopy where LiDAR just can't really penetrate down to the ground level. But in sort of moderately dense vegetation, you can still get really good ground level data from the LiDAR.
And how data heavy it is, right? So you just mentioned millions of readings or whatever. Do you typically transmit in live time back to the cloud or something, or is it stored on a data logger on the actual drone?
So all the photos that we do are stored on the drone. Some of the survey drones we've got have 40 megapixel cameras, so the photos are like 12 meg each. So they definitely fill up a hard drive pretty quickly. And then the LiDAR, I think there's options for the LiDAR to, like, I guess it's stored on the drone. We don't operate any LiDAR at the moment, but then there's real-time updates, I guess, that the controller will see as well. So that is one of the risks, I guess, that I might chat about next, is things like managing your data. So looking after your data, and then also we had some teams out doing some coastal mapping yesterday, and one of the little bits of advice I gave them was after every flight, download the data that's on the drone, because they're flying out over the water. If their drone, something happens to their drone and they ditch into the ocean, then at least they've got the data that they've already collected. It's not all still on the drone at the bottom of the ocean. So they're not starting again with a different drone tomorrow.
Drones float if they crash in the water?
They can. The ones I've crashed haven't floated. So it did catch on fire after it fell in the water. So
Right.
yeah. So yes, water and drones don't usually, although you can get waterproof drones. So one thing that's good to keep in mind is that although drones are really cool and it's a good talking point, they're not always a silver bullet for environmental monitoring. There'll be places you can't fly. There'll be places you can't get to. The area might just be too large, and you'll spend a month out there collecting data that maybe you could have used a satellite for. So there's just this is just a slide of some things to consider when you're thinking about using drones. So considering the airspace, maybe it's in restricted airspace from defence, maybe it's at the end of a runway. So using tools like Open Sky or OK to Fly to find out whether you can fly there. And if you do need approvals, there's ways around it, but there is often a lead time for those approvals. So sometimes it could be 6 weeks before you can go out and collect the data on site with the right approvals. Thinking about the height above ground level too. So sometimes even with the approval, maybe you can't fly as high as you wanted, or sometimes you need to fly lower to collect the amount of detail that you need, which will make your mission longer. There's some considerations too about line of sight. So there's different rules about how far you can fly when you can see your drone, which is that VLOS, so visual line of sight. And then there's extended visual line of sight and beyond visual line of sight. So normally in the standard operating conditions for flying a drone, you can only fly the drone as far as you can see it, which means you can't sort of stand somewhere and then send the drone off a kilometre or two away, collecting data and then hope it comes back to you. You need to be able to see it and I guess tangibly see what direction that it's facing. So that means you might have to do more setups. So if someone said they wanted you to fly a 50-kilometre pipeline or even a 10-kilometre pipeline, you're not going to be able to stand at one end and send the drone off and back without setting up multiple times along the way or seeking those additional approvals.
What was EV? EV loss?
EV loss is extended visual line of sight. So that could be you as the pilot have a friend 600 meters away with a radio and they can see the drone another 600 meters beyond that. Or you've got binoculars and you can see the drone further away. So it's sort of like an assisted, you can still see the drone, but you're using some assisted methods to do that.
BV was beyond.
Beyond. So that's sort of like some of the mining companies now have a drone in a box that just sits on the site. And then from the office, they can plan the mission. The drone will come out of the box with no one there, go and fly the mission and then land back in the box again. So that sort of thing would be an example of beyond visual line of sight.
So do you need a different license for those different definitions?
Yeah, so the visual line of sight is sort of, you can do that with no license or you can do it with the sort of standard organization license, so the operator certificate. And then the extended visual line of sight and beyond, you do need extra approvals, extra training, extra risk assessment. So it's all possible, but yeah, you've got to go through the right process and have the right procedures in place to do that.
So you said with VLOS, you may not need to have a license at all. How does that tie into like your standard OH&S like protocols and things would?
Yeah, so every companies are different, I guess. So in Australia, you can legally fly a drone for commercial purpose under 2 kilos. So it could be a little drone. There's things you have to make sure you're doing in terms of not flying over people and not flying at night, that sort of thing. So you can fly some of those smaller drones without a license. I guess Stantec's made a decision that all of our pilots will have a license. So that just means that's just a company decision that any of our pilots that are flying have a license. But yeah, there are ways that you can fly some little drones, but anything over 2 kilos, you automatically need a license. And then there's different weight levels as well. So there's a 7 kilo is your sort of entry level license. There's a 25 kilo, and then goes up from there. I think they go up to 150 kilos, which is a pretty big drone.
I find it pretty extraordinary you can fly a drone without a license at less than 2 kilos. Like, what's the assumption that you won't be able to cause any damage with something less than 2 kilos? Like,
Yeah,
how do people know the rules? Like,
yeah, it's a good question. I guess it's a bit of an honesty system. There are operator accreditations, which I think you might need to do if you're flying for commercial purposes. But they're free. But check the CASA website because we just fly with licenses, so I'm not all that familiar on the under 2 kilo rules.
right.
But yeah, all that info is on the CASA website for operator accreditation.
Yeah.
All right. Some other things to consider are things like tides. So some of the work we do on beaches, we want to try and fly at low tide, which could be in the afternoon when the winds are up, and that means it's not a great time to fly. So might mean that your lead time for doing the drone survey on a beach, for example, if you're trying to work around the tides, you're trying to work around the tides and the weather. So not raining and not windy. So it might make it more difficult. And then the time of day as well, just depending on what you're collecting, you might have too much glare or too much glare off the water. So if you're looking for something that's just offshore a little bit for sort of seagrass mapping or something like that, if considering the time of day, that you're not just taking photos of the sun reflecting back at you from the water. So all these different things that you can think about. Traveling with batteries is a big one. So there's some information from CASA, like, can I pack that? So usually all your batteries, the spare batteries need to come in your carry-on with you, but then your carry-on can get pretty heavy pretty quickly. Or maybe sometimes we mobilize our drones via road beforehand. But again, all of that takes time. There'll be other things to consider, like equipment calibration. So you might have the sensor, but if it's not calibrated, you're just collecting data that doesn't maybe mean anything. And then being able to interpret the information afterwards as well. So like I said, you might have a multi-spectral camera on your drone, which is great, but maybe if you don't calibrate it and you don't know what it means, then maybe you don't know what to do with the data. So you can collect information, but you need to be able to know what it's doing.
You I guess just thinking about the audit system and for environmental applications, have you had the instance where your measurements that you've collected with the drone have been audited?
No. So we don't have any multispectral sensors on our drones, but when we do survey grade drone work, we've got a survey team. So if we're verifying the accuracy of our drone survey, we've got the surveyors there, and they've given us like a letter, I guess, to go as part of our metadata to say this is the accuracy that we've captured the data to, and this is how we know it's accurate, which survey marks we've tied it back to, and that sort of thing. So yeah, it's definitely something to keep in mind, is just collecting that information at the point of capture, which is sort of that metadata of how you collected the data, so that is defensible, I guess, later if someone's asking you how you got the
Yeah.
results you got.
So you mentioned earlier about methane monitoring and people using it for that application. So I guess the question around calibration, that was what I was thinking about. Like at the moment, people they can walk around manually, like with a laser device, etc.
Mm.
Um, I guess I've got two questions. So how does it work? Is it a laser sensor that you're talking about there? Do you use them at the moment at Stantec?
Our field teams probably do. I don't, but yeah, we're not using them on our drones at this point.
All right. Um, shall I scroll to the next slide?
Yeah, so we'll move on to satellite. So think of so what our drone program is quite a discrete area, whereas satellite, you can task a satellite, which sounds pretty cool. You can tell a satellite that I would like a photo captured in a week on this day, and it will give you back an image, assuming there's no cloud cover. So it lets you capture a bigger area. So you can normally, I think if you task a satellite, the minimum order size is 25 square kilometers. So that's sort of the scale that one satellite picture, I guess, will come back with. But you can do this on like a country scale, global scale, a whole LGA, that sort of thing. So it just sort of scales up the amount of area that you can do this analysis for. I guess one of the limitations, which I guess I'll talk about later as well, but just with being able to cover a larger area, you don't get the resolution that you do get with the drones, but you can cover a bigger area. And there's always new satellites, different constellations being put up into space with different quality sensors and different different arrays of satellites, and it's always just getting better and better. So I think pretty much the standard satellite imagery at the moment is 30 centimeters. So we talked before about sort of 3 centimeters for a drone, about 10 centimeters for a plane imagery, and then 30 centimeters for a satellite. So that's how big each pixel is if you zoom right in. With the satellites as well, because of the volume of data, you could use things like AI and machine learning to help process the data. So the satellites vary on how often they repeat or cover a particular site. So some of the satellites will cross over a particular site daily. Others might be once a week, they'll fly over your area. So there's different considerations on how often you want the data collected. But if you're capturing an image every day of the same site to monitor something, or every week, then you're going to end up with a lot of data as well. And all of this information can keep feeding into. So we talk about digital twins as kind of being like a digital twin of a city or something like that. But I think there's an argument to be made that digital twins can be like a digital twin of an environmental thing as well. So digital twins really just a digital representation of something that's happening on the Earth as well. So if you're getting daily data, you can almost be processing things in near real time and have little lag, I guess, in terms of analyzing some of the results.
That's really just a new term for what we're doing already.
Yeah, that's right.
Just a bit of lingo. It annoys me a bit, that one. So I came out of nowhere.
Same but different.
Yeah.
And then on the next slide, we've got some benefits. So similar to the drones, cost saving is a particular benefit. So being able to monitor a wide range of information continuously over a big area. So the time it might take to go and get field teams out to do ground surveys, when you could do some of this sort of large area mapping with satellite as well. However, there's always benefit to the ground truthing, because if you're just doing everything on a with like remotely sensed data and no ground truthing, you might be introducing error into your results. So there's always a place for ground truthing. Gives you a unique perspective. So gives you information that you might not have had access to before. So you can make informed decisions on a big picture scale. And like I mentioned, the high frequency. So some of the information you can get on a daily basis, it might be more coarse. So the pixel size is bigger, but you can get a lot of information there as well. And you can get information dating back to quite a long way. So there's sort of, since the 90s, maybe 80s, there's been satellites out there collecting information. So if you're looking at long temporal trends over a particular site, you can go back quite a long way. And some of the satellites are pretty similar. So I think maybe it's Landsat has been out for a long time. So the information that's being collected is consistent over that same satellite series. And then health and safety again. So reducing the amount of field surveys required. If you can go and inspect a site that's really remote or really hazardous without going there, then that's great. And you can do desktop assessment and then identify hotspots or particular areas that are maybe anomalies that you want to go and do some ground truthing or further investigations in the field with. But it lets you get a big picture in a relatively short time frame.
You typically go direct to the people generating the satellite data, or do you go through like a third party that's processed that into the sort of parameters that you want? So how do you normally go about that?
Yeah, so there's different options. So there's groups like Planet or Skywatch that you can create an account and task a satellite. So you can go straight to the companies. I guess they're all still reselling the data. Some of them, I think Planet's got their own set of satellites, but they, yeah, so you can, if you're tasking a satellite, you can go back to those sort of companies as well. Or there's other groups, I guess. So can't think of the name at the moment, but you can go and get historical data as well. And then there's places like Sentinel that are freely available satellite archives as well. So yeah, there's both options. You can go straight to the task the satellite from the satellite people, and you can go and get them from resellers.
We've done quite a lot of work with a company called Cybo Labs, who I guess they're a reseller, if you like, but they run a whole lot of it through their own algorithms to, they do things like biomass in paddocks. They've mapped the whole of Australia for biomass. I mean, it's kind of
Yeah,
amazing what can be done with it.
yeah, yeah. So you can get the I guess the raw images of vendors, or you can get to some of that processed imagery. You can buy it that's not georeferenced, and you can buy it that is georeferenced or auto-rectified. So if it's really hilly, you can get it so that it's sort of corrected for the hill, the terrain, which is probably good for really hilly countries like PNG or something like that, where it's just going to get a bit distorted with that sort of terrain. So yeah.
You sometimes find it hard to decide whether you need to use a drone or satellite, like just making that decision on the resolution that you really need to manage the thing. Do you sort of, is that a tricky
Yeah,
zone?
I think some of the decisions on even just drone and getting a subconsultant to fly with a plane is just dependent on like our internal mobilization costs and if it's how big it is. Like if it's going to take us a while to collect the data on foot, I guess using the drone, then we'll sort of step up to the manned aircraft options or helicopter. And then if it's bigger again. So it sort of depends on the scale of how big the area someone wants to look at is.
Yeah.
Will depend which option we choose.
I can imagine it's hard because we're always making decisions on any sort of assessment, how many holes do I need? How many measurement points? But effectively, it's the same question, isn't it? But
Yeah,
different
yeah,
way. Shall I move to the next slide?
yeah. So this slide's got some other opportunities, I guess, of what you can do with the satellite information. So way back at the start, we talked about things like infrared or thermal, radar, multispectral, hyperspectral. So there's all kinds of different sensors that you have with a satellite option, and things that you can do with the information sort of opens up more opportunity. So for things like environmental monitoring, you can look at change in elevation over time, I guess using things like radar. You can look at water quality and turbidity. I think if you click, the other photos might pop up. So that one on the right is using INSAR, which is a radar image from the satellite, looking at vertical displacement over time. So that's one opportunity. You can do things like water quality and turbidity. You can also look at methane and temperatures, soil moisture. There's a whole bunch of different things you can do with the satellite, but sometimes the pixels will be really quite big. So sometimes the pixel could be 30 meters big. Yeah, it's that's when you're looking at more sort of larger trends across an area. And vegetation and land cover, that sort of thing's really well established in terms of using satellite for NDVI and vegetation health condition, looking at identifying vegetation and how vegetation is changing over time or deteriorating or improving, looking at things like biomass and land cover classification. So if it's bare ground, vegetation, urban area, roads, that sort of thing. So that's sort of some of the opportunities for what you can use satellite information for.
You done much with the water quality side of things?
I think one of the other examples.
You want me to scroll on?
No, it's okay. There's one a bit later with some water, but it's more about turbidity. Yeah. On the next slide, there's an example of. Click again. There's some water information, like you can do chlorophyll or turbidity, suspended solids, that sort of thing. So you can get that out of some of the satellites, and our teams in North America have done a bit more of that than I have. But yeah, there's lots of opportunities, I guess, for larger scale monitoring. Some of the limitations with the satellite can be that you get cloud cover. So particularly if you're trying to look at maybe an area that's been flooded or there's sort of some natural disasters been happening in the area. If it's associated with flooding or rainfall, you might find that the area is still hiding in the clouds. And so radar, like I mentioned, will see through the clouds, but generally you might just get an image back like this that has a cloud conveniently where you were looking to get some information. And if you do task a satellite, you normally nominate what sort of cloud cover level is acceptable to you, or it might just be something that they've come up with, but your whole image could be cloud free except for the little patch that you want, and then it's 90% cloud free, which meets the threshold. So there's some challenges if you're doing tasking for satellites, and yeah, you might get some of that cloud cover. Resolution can be, like I said, not as good as the drones, obviously, but you can do different things with it. And the data sets can be quite large again. So there's always a bit of a data storage and management challenge as well. I mentioned some ground truthing before. So even though you've got all these sort of remote sensing Earth observation opportunities, there's still benefit to going and just checking on the ground that actually that's what you're observing is happening from the sky. Sometimes you need specialized software. So there's a lot of GIS packages that have sort of image analysis and some image machine learning capabilities in them. But sometimes you might find you need specialized software to process some of the particular images that you might be using. And then being able to know what you're looking at. So being able to make a pretty picture is fine, but if you don't know what it's a pretty picture of, then yeah, it's a pretty picture.
We did another webinar with the CSIRO Aquawatch teams, maybe 6 months ago, and they're using it to detect algae. And then these hyperspectral base stations called hydrospectra to improve the resolution. So it's pretty amazing what they can do. So if people are interested in that, just go hunting for the recording on our website and have a look at that. Shall I move to the next one?
Yeah, go for it. So I'll move into a couple of case studies next as well. So the first one, we've done a few sort of coastal geotechnical risk, beach and coastal monitoring examples. So the drone examples I'll share are more around that. So this was one project we did which had 2 sites in with New South Wales National Parks. So looking with our geotech team on risk assessment for potential rockfall. So assisting national parks with potential walking trail upgrades and looking at potentially hazardous cliff lines. So there's in the photos a rock shelf, which it was probably 20 meters wide, but it was about a kilometre back from the beach that you could access it from. So being able to come in maybe from the top or send a drone up just meant that we had a lot better window to assess the area without the risk of some giant waves overtopping the rock shelf and washing anyone away. Plus, we were there to look at geotechnical risk and rockfalls, and so walking at the bottom of the cliff was probably not preferred as well. And then we used tools like Bentley, I think it's called iTwin Motion now, or it was context capture, to stitch our our photogrammetry together to get really high resolution 3D model of the cliff line as well, which then our geotech could use to complete their assessment. And then on the next slide is just a bit further down the coast. We did something similar further down and could collect similar photogrammetry of the coast, but looking a little bit more about potential for areas that might be being undercut by any wave action, which is not really something you could see from the shoreline. That being able to go out and fly over the water and look back at the cliffs to look at any sort of potential erosion or dangerous sections was really valuable. And yeah, just meant that we could see things that even if you got on a boat and were looking back, it would be really difficult to see the sort of things that we were looking for as well. So yeah, that's that one. Next examples with the drone is doing some beach and coastal monitoring. So there's a bunch of state and local councils that we work with for looking at things like beach renourishment or beach erosion, or just monitoring over time. So looking at things like coastal hazards and vulnerability studies, trying to work out which parts of the beach are more vulnerable to erosion, that sort of thing. So looking at how we can help our clients come up with options for risk mitigation, maybe seawall or groin or something like that will just help manage the beach. So some of these we do quite regularly, maybe every 6 months. Some of them we've been doing for sort of over 10 years, doing beach surveys like this. But the drones are really valuable for collecting this information. Not a bad day in the office either. And there's also just a picture. Some of the coastal work we do use the ROV as well. Not so much on the beach, but I found that photo and I was like, it's just a good example of other remote sensing opportunities for coastal monitoring. And then the next slide just has some challenges, I guess, with what we do with the beach monitoring. So usually people at the beach. So just being able to trying to work around people that are on the beach. You've got to be a bit more flexible on breaking up your beach into sections and managing not so much crowd control, probably not a crowd, but just managing the safe operations over a public place like the beach. And operations over water as well is pretty not tricky, but it's just something you've got to plan for. So things like I mentioned, making sure that you've got the SD card, backing up the imagery as you go in case anything happens to your drone while it's out over the water, and things like eagles and sea eagles, and making sure the lighting isn't impacting what you're trying to look at when you're over the beach, or the near ocean as well. One of the other challenges with the water is just being able to stitch the photogrammetry together. If your photos are just water, 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 and it all looks like the same thing, the software is going to struggle to stick it all together into a meaningful image as well. So yeah, you can fly out over the water and take lots of pictures, but if there's nothing for the imagery to stick together, then it won't work so well.
You mentioned earlier about certain time of day because of the reflection off the water surface. So what do you normally do? Get up really early for sunrise? Is that sort of how you do it?
It doesn't need to be sunrise, but yeah, normally for the coastal stuff, we found like the wind is less in the morning, and when the sun's not like midday. Normally, when you're not over working with the water, normally middays when you would normally say you need to capture it, imagery, because there's no long shadows and that sort of thing. But for flying over water, flying in the middle of the day when the sun's looking straight down at the water. So yeah, morning would be when we would try and target our beach surveys because less chance of there being the wind that comes up in the afternoon, and then the sun's not directly overhead either.
Have you seen any sharks, Amy, on your surveys?
No, but our aquatic ecology team has started using drones to help them when they do their dives with a shark spotting drone with them.
That's when you need to have a good team, isn't it? No internal
Yeah.
politics.
Yeah, exactly. Yeah. And the last two case studies I've got are some satellite imagery examples. So these are examples that our remote sensing teams have been working on. So things like using satellite imagery, a daily satellite image to create a sort of blended image that shows the things like water quality, algal blooms, turbidity, and temperatures, and how that's changing over time. I'm not too savvy on how they're doing this, but they're talking about using synthetic imagery, so it sort of fills in the gaps using some sort of predictive analytics of what it expects should be there, but gives them a good picture of some potential real-time water quality monitoring over a pretty large area as well. I think if you click again, there's another photo.
With your metadata, so if you use a synthetic image, so you've got half of it's real and half of it's made up by AI, is the metadata attached to each individual pixel, or how do you handle that?
Ooh, that's a good question. I think that'd have to be an associated report that goes with it that explains the methodology behind it. But ultimately, it's the date and the time of the imagery and what bands were used, I guess, in the analysis.
It's an interesting zone, though, isn't it? That one.
Yeah. And then the last example we sort of touched on it a little bit was things like looking at biomass and like potential carbon offsets. And so this methodology uses LiDAR and near infrared. So LiDAR from a plane or a drone, and near infrared imagery from satellite to measure the biomass and calculate potential carbon dioxide equivalents as well. So looking at how the vegetation is working in that sense. So using things like NDVI, using the red and the near infrared bands from the satellite to look at how much biomass each plant has. And you can do that over time. So might be something like mangroves, looking at how that's sort of changing over time, or and help you assess particular sites or prioritize different sites as well for different environmental applications or offsets or protection.
With those sorts of measurements, are you publishing that with a error band?
I would say so. So I think, this is something our North America team's doing, but yes, I think they would be putting that in there.
We had I'm not sure if it was a webinar or just presentation on using terrestrially based LiDAR, and it spins around in a forest and it measures the woody component versus the leaf component. I'm trying to remember the error that they said for comparing. I can't remember if it was plane based or drone based, but it was something like a 40% error in, the estimation of the CO2 that would have been sequestered, because they only count the woody stuff, right, not the leaves in that calculation. So I was furious on that, I guess.
Yeah.
All right, we better move on because we've got all those early bird questions.
Right. Yep.
But that was fantastic, Amy. Are you ready for a few
I'm
questions?
ready for some grilling. Yeah.
All right, here we go. First question, regional scale monitoring of ground cover levels in pasture and grazing land.
Ground cover levels. So I think things like using the like image classification is something where you could look at different ground cover. I don't know in terms of the nuanced changes, I guess, in grazing land. Some of the multispectral imagery or hyperspectral, you can try and pull out different species, but I guess it depends on how similar those species are. It's definitely easier to work out trees and grass, but different nuances in pasture and grazing land. Yes, anything possible.
That company, Cybo Labs, that I mentioned, they produce a report that gives you things like percentage woody vegetation cover versus pasture and versus bare ground, that sort of thing. So it's definitely available from a satellite perspective. Next question. In your experience, how easy or difficult is it to obtain permission for flying drones within protected airspace?
So we talked before about being able to fly without a license. If you're flying in restricted airspace, so like defence, or like sometimes there's restricted airspace around Sydney Harbour, that sort of thing. So there's different airspace like that. Or within controlled airspace, all those things you can't do unless you've got a license. So there's limitations there. Once you've got a license, we have signed up for there's a automated airspace approval trial, which I think has about 6 or 7 locations that you can get automated airspace approval for. So Sydney Harbour restricted area being one of them. So that has simplified the process without end. It's been amazing. Normally it would be a 6-week, $800 process, and you may or may not get approval. But yeah, this has just been a bit of a game changer. So if it's one of those sort of 7 areas, then really easy. It's more just paperwork. So all the paperwork for safety documentation and that sort of thing to be able to submit with your application. So we have got approval before from CASA to fly over like in the Melbourne CBD somewhere. So there's approval, but you just got to go through the right safety processes and things like making sure that people aren't coming in and out of a particular building at a time, and that there's communication, that sort of thing. So, but yeah, the lead times can be make things a little slow down a bit.
How long does it take to get your license?
Yeah, so the typical process to get your remote pilot license is a 5-day process. So there's 3 days of theory and 2 days of practical, and then you can get your license.
All right. Next question. How actively, I think, is industry relying on drone technology? What's your sort of pretty broad question. You might want to narrow it.
I think it's an extra tool in the toolbox, so to say. I think I don't know, we're reliant on it in a bad way. I think we're reliant on it in that it's opening up more opportunities to be able to capture information that we've never really captured before. So I think it's relying on it in a good way, but yeah, I think it's giving us lots more opportunities.
So you think it's improving management?
Yeah, I think so. Yeah, like the coastal monitoring stuff would be done with a maybe a plane, and you wouldn't get the level of detail that the guys are getting at the moment.
You really need to be there. Like you talked about programming drones. Like, so if the council's doing a beach every year or wants to do it every 6 months, would they be better off just to buy a drone, have it programmed, and then Stantec just do the data processing?
Yeah, potentially. I think like there's definitely places that like some of them are like software as a service options where you can just throw your data into it and it'll process it and give it your results. I guess it comes back to the safety and the risk part of it. So yeah, and how that's managed maybe at a council level or within the contractors. But yeah, a sort of busy spot like a beach, I don't think you could quite do without having people there.
No different to people
Unless it's
zipping
an
around
empty
in
beach.
jet skis, Amy.
Yeah,
But
that's right.
let's move on. Any tips for monitoring changes in vegetation condition?
So vegetation conditions are pretty, I guess, easy formula. So any of the 4-band imagery that you could get from a commercial satellite will let you do NDVI, and NDVI helps you, I guess, look at how vegetation condition or vegetation health is changing over time. More on a greenness index, I think, but yeah.
Do you ever use a drone as well, or are you typically just doing that with satellite?
Yeah, we're just doing it with satellite at the moment because we've just got the color imagery on the drone.
Right. All right. What about silica dust?
Yeah, I'm not sure, but I think if you can measure things with a handheld sensor, you should be able to do it with a drone, but not something that I've come across.
Next question. Do you envisage drones eventually replacing traditional field surveys altogether, or will they always be a complementary tool?
I think they're pretty complementary at the moment. So I think it might be that you do 6 months of field monitoring and then have a month where there's a on-ground field survey, that sort of thing. So maybe the interval between the field surveys might become longer. But I think there's still going to be a place for that ground truthing and the validating the results that you're getting from drones or satellites. So I think they'll still be complementary. Same with the doing survey grade work as well. Still need a surveyor on the ground to pick up some levels, even if you've got RTK or PPK on your drone, still picking up some check strings or some ground control points. Still important to help verify the data.
All right, next question. How, using AI within drone data capture, can you automate environmental assessments and survey?
I think that comes back to having the repeatable data. So if you're going and doing the same site over and over again, you get that library of data for the same site. And I think it's probably more a bit like image analysis or machine learning, looking at the same image over and over again. But yeah, so there's a lot of image analysis tools in like Esri software these days as well. There's more and more tools coming out that are standard image processing tools. Don't know if that answered the question, Pat.
Yeah, I think it does. Yeah. This person's interested in the analysis of the imagery produced by the drones. What bands, ML models are being utilised? What is an ML model?
A machine learning model.
Machine.
But I'm not sure.
Not quite sure.
Yeah, not quite sure. But like I said, there's a lot of image analysis and deep learning machine learning models in Esri software that's sort of becoming more and more. So you can start training some of the data. But I couldn't really comment on particular models.
Okay. Next one. How do you suggest approaching clients with newer technology like drones when so many are reluctant to spend dollars on work beyond the normal?
It's
Good
challenging.
question.
Yeah, internally, like, yeah, wherever you are, I think you've got challenges of trying to get investment in new technology when people want to keep doing it the same way or aren't really sure about it. I think drone technology is changing so much that I think if you're not getting on board as well, you're going to get left behind in some aspects. So it's just becoming the norm. And if it's not something that you're offering or involving in your workflow, I think it's it's going to be a challenge.
Do you feel conflicted in that statement, Amy?
I do. Yeah.
Next question. I'm just staring. Drone pilot license application to mapping for erosion remediation on creeks. I think they mean, have you used it for mapping erosion?
Not specifically for sort of creek erosion, but yes, you could definitely monitor how the bank is changing or look for sort of undercuts and changes to the creek. I guess the challenge with using the drone for that is that visual line of sight thing that we talked about before. So being able to keep sight of your drone, so particularly on the sort of unlicensed or even with a license, if you're flying visual line of sight, you can only go so far up a creek. We have landed drones on boats before, so if the creek is big enough to drive a boat down, you could look at taking your drone with you and doing some flying off the boat. So that's an option as well. And then you're kind of following the drone along while you're in the boat.
I know the Malone Institute that do their catchment scale stuff have used drone-based LiDAR for looking at the morphology of the stream beds and things, and it was really successful.
There is shallow water bathymetry LiDAR options as well. I don't know too much about it, but there is LiDAR options that do the shallow water as well. So you can kind of transitions from the terrestrial into the nearshore water as well.
All right. And last one of the early bird questions. Do you think drones coupled with multispectral sensors can accurately assess variations in water quality?
Mm. I think it's not sure about the accuracy, but definitely looking at trends over time. Um, so being able to identify patterns and how something's changing, maybe I think the Water Watch example might have been a daily compile of imagery. So I think that's where the ground truthing still comes into it, but being able to monitor something remotely every day for a month and then identify where you need to do some ground truthing. So
Yeah. With that AquaWatch example, that's SRO one, they have these base stations that float on buoys and they use that to ground truth. So it's effectively
yeah,
the same sort of scanning device, but it's ground truthing it that way.
yeah, that's right. Yeah, so yeah, it doesn't need to be people in the field ground truthing. It could be a boy or something like that.
Right, now we're over to the Q&A. You ready?
Yeah.
Okay, here we go. One from Mark Beaudry. Not really a question. Oh, you're off the hook. You should mention that drones typically need trained operators, pilots to get the accuracies you were talking about. They need to be able to keep very accurate path baselines and be able to land safely to protect the camera sensors. Cannot just be flown by anyone on site.
Yeah, that's right. And some companies that we've worked with need extra approvals again to fly on their sites or extra audits, that sort of thing. So yeah, not a magic silver bullet. There's always some extra paperwork to do for sure.
All right, a next question, anonymous attendee. Use another drone to watch the first drone, extended line of sight. Can you do that?
I'm not sure.
There you go.
Yeah,
That sounds like cheating, doesn't it? But
that's a little bit, but
big drone with a person sitting in it, I think that might be counterproductive. All right, next one from James Ross. How difficult and how long is the process to gain approvals for BV loss?
mm,
Is there a broad approval one can get, or does approval need to be sought for every flight or job?
yeah. So it's not something that we've done, but my understanding is you need to get the beyond visual line of sight attached to your REOC. So you as an organization need to have the beyond visual line of sight qualification or um, procedures in place, including all the safety components. And then I think you can probably get a bit more of a blanket approval if it's the same site over and over again. But yeah, I think it's once you've got the beyond visual line of sight on your REOC, I think it's then all managed internally.
Okay, here's a good question. How can we use remote sensing methods on the flatback turtle monitoring?
Sounds like a Stantec person question. That's a good question. Um, I guess you could be looking at things like tracks. You know? Yeah. I don't know.
Could you pick up a turtle with satellite? Like, what did you say? It's down to
Ooh,
10,
30 centimeters.
30 centimeters. That's a
Yeah.
mid-sized turtle,
They're
isn't it?
big, yeah. I think flatback turtles are pretty big. But um, yeah, I'm not sure right now.
All right,
Um,
that's one to chat internally
yeah.
about by the sounds of it. Um, how can council use this technology to conduct regular inspection in the mining areas?
Mm,
Because they come from a mining
yeah.
town.
So I think there are councils using drones for things like looking at encroachment or verifying, I guess, DAs and that sort of thing. Um, I guess it does become a bit more challenging. You probably can't just go and take your council drone and fly it over a mine site. So yeah, I
I
think
know
it's
you mentioned earlier about measuring dust, or there was the question about silica dust.
mm,
What about just satellite imagery for looking at extent of dust plumes? Is there any application in that side of
um,
things?
I'm not sure. I think looking at this other slide deck, I don't think there is one thinking. No, it's not going to show it for me. But I think you can do um, some air quality. Yeah, I thought I did have a slide here about it, but there is some air quality that you can do with satellites. I'm not quite sure what sensors though. Um,
All right, we'll take that one on notice.
yeah, that's right.
Um, Now, this one is going to require some honesty. Have you ever lost a drone into water, up a tree, or in scrubland?
I have
Is
lost
this
a
an
drone.
internal stitch up,
No,
Amy? Is
I don't
this
know. I don't. But I have lost a drone. I have lost a drone in the ocean. So I don't know, like a malfunction of one of the arms on the drone took off the beach, went out over the ocean, and then it did a death spiral and then ended up in the ocean. It wasn't so far in the ocean we could still get it back, but then it caught on fire when we pulled it out of the ocean. So yes, and various near misses with eagles. We've had a couple of drones taken out by an eagle. We've lost a drone in a pit lake. Um, so yeah, there's I think when I was talking to someone before, if you haven't had any incidents with a drone, I guess on a safety perspective, good to keep track of them all. But if you, yeah, something's gonna happen, whether it's user error or mechanical error or battery failure. So got to be prepared for it, and that's why flying over people and beyond visual line of sight is important consideration.
I heard of a case where the frequency of a microwave oven affected the navigation of the drone.
Mm.
So an on-site has been a case on it. So it caused a major
Issues, yeah,
OH&S issue.
yeah,
So have you had
yeah.
that come across it?
Mm. I don't know, maybe not that one specifically, but yeah, there's all kinds of things that you wouldn't think would interfere with a drone. Um, that
That
could,
could.
yeah,
Yeah.
Wi-Fi, all kinds of, yeah.
All right. Next question. Hi, Amy. How can drone and satellite data be used for site-specific compliance reporting? And is there or a contaminants we can detect getting an idea about water color? Also, which technology is used to measure turbidity using drones?
Um, so, um, I guess we use some of the drones for like landfill monitoring or rehabilitation, for looking at, I guess, how the site's being remediated over time. Um, the contaminants about watercolor. I guess you can look at how, um, how the imagery is changing color over time. Um,
I think that ties in with that Cyro presentation. They do cover
yeah,
that. So maybe have a look at that other webinar. It sort of covers a lot around water quality
yeah.
filters.
And I think the turbidity, I'm not sure about drones, but I think it's Modus and Sentinel, I think, let you look at turbidity um, over time.
Have a look at AquaWatch. That'll have all the
Yeah.
tech in there. Stephen Chan says, thanks for sharing. What is your most interesting find from geocaching?
Okay. Um, I have found a geocache that was just a rock with a little logbook in it. Um, what's another one? It does take you to some good places. So on holidays, moving to new areas, I think, yeah, helps you explore different places. Um, but yes, definitely some quirky ones out there. But yes, definitely spending probably an hour looking for a rock. It was definitely a memorable one.
All right. Andrew Wallen. Good to hear from you, Andrew. Is anyone working with satellite technology to assess soil and or plant nutrient profiles?
Mm. That's a good question. I don't know.
All right, we're going to
Could
take
that be
that
my
on
answer?
notice,
Yeah.
Andrew. Bit of a tricky
Yeah.
one. And Dr. Brent Davey, have you developed any effective anti-eagle measures that protect both the drone and the eagle?
I've heard lots of stories. I don't know how effective they are, but I've heard things like putting painting eyes on the top of the drone. Like some of our fixed wing drones that look more like a bird can put eyes on the top is one theory I've heard, or reflective tape. Yes, I think it's the way that we've been dealing it with is more knowing some evasive maneuvers. So one of the things when I did my drone license, I was taught eagles don't like if you fly up. So if an eagle is coming for you, if you go up, they take a second look.
Is that if they're coming from below you or above you?
No, they attack from above.
Right.
But
So
they come in pretty
you got
quick.
to play
Yeah.
chicken with them, do you?
Yeah. But yeah. Normally, if you've got an eagle after you, you kind of fly up, hope for the best, and land as soon as you can, and then come back later because they're not going to give up.
Okay. Amy, that brings us to an end of the questions. Thank you very much for presenting today, and
No
thanks to
problem.
Stantec as well. But that was really good. So many thanks for that. Really appreciate it. And thanks everyone who attended.
Excellent. No problem. Thank you.
Bye for now.